Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today we are going to extend the concepts of work energy and power, and we will talk about gravitational potential energy and kinetic energy. So let's first talk about gravitational potential energy. Gravitational potential energy is given by this equation, which is equal to m times g times h, where m is the mass of the object, g is acceleration due to gravity, and h is the height from the ground. So let's look at how this formula of gravitational potential energy comes. Suppose there is an object of mass m at height h from the ground. This is ground. Okay. Now, at the ground, the potential energy is taken as 0. Okay. Now, suppose you are trying to lift this ball from here and you are bringing it up to this height. So what happens? When the ball is here and is having mass m, so its weight mg is acting downward, right? So you will have to apply a force which is equal to mg, at least equal to mg. It may be even more than that, but at least equal to mg, to lift this ball from here and bring up to this height. Okay? If you are lifting the ball without any acceleration, then at least the applied force must be equal to the weight which is acting downward. Then only you can move this ball without accelerating it up to height h. Okay? So this force must be equal to mg. Okay. Now try understanding this. You can lift this ball to this height by accelerating it also. Suppose you applied a force which is greater than mg. Suppose the weight mg is say 10 Newton and you applied a force of 12 Newton. So of course it is greater than 2 Newton. In that case, the net force of 2 Newton, 12 minus 10, that will be acting upward. Right? So 2 Newton force will be acting upward. If a net force is acting on a body, the body moves with acceleration. So you cannot move this body with a constant speed up to this height. Okay? If you want to move this body at a constant speed from this height, which is always considered a kind of assumption that if I am moving the body, I will be moving that with a constant speed, that is without acceleration, then at least the force must be equal to mg. Okay? But you can move with acceleration also. In the case which we are discussing, the derivation of gravitational potential energy, we will consider that the ball is being moved without any acceleration. Okay? So for that, the case is that force is equal to mg. Okay? But now you can also have a doubt that if force is equal to weight, then how the ball will move? So this is an assumption taken that just to initiate a bit of motion in the ball, you will have to apply a bit of higher force than mg, and the moment the motion starts in the ball, then it will bring the force down, which is exactly equal to mg, and then the ball will move with constant speed up to height h. Okay? This part is not elaborated, but be clear about it, that for initial motion you will have to apply a bit of higher force than mg, and once the ball starts moving, then bring it back to mg, and then with constant speed, that is with zero acceleration, you can move the ball up to height h. Right? Now, if that is the case, then what is the work done by the force which you have applied on the ball in bringing this up to a height h? We know that work done is equal to force into the displacement in the direction of force. Okay? Here the applied force is in upward direction, magnitude wise which is equal to mg, and the distance up to which the ball traveled from ground up to height h, that s is equal to h in the direction of force. And therefore this work done on the ball by u will be mgh. Now this work done itself gets stored as a gravitational potential energy in the ball at height h. So you can write u which is equal to mgh, assuming that the potential energy at the ground is 0. That's how you get the equation or the formula of gravitational potential energy mgh. Okay. So if there is a body which is at height h, its potential energy is mgh. Suppose there is a body at height h1, then its potential energy u1 will be equal to mg times h1 with the same concept. If suppose the body is at height h2, then the gravitational potential energy will be mgh2, right? Or you can say that the work done in moving the ball from height h1 to h2, that is change in gravitational potential energy, will be equal to u2 minus m1 u1, which will be equal to mg times h2 minus h1. Right? So this is the way you derive the gravitational potential energy, and you can use this formula anywhere you have to identify the gravitational potential energy above the surface of the earth or from the ground. Okay. Now let's talk about the kinetic energy. So how kinetic energy and its formula is derived. So how the kinetic energy is derived. So suppose a body is moving with a velocity v in this direction, okay, and you applied an opposing force F in the opposite direction. So what is your natural expectation about the speed of this body? Because you are applying in the opposite direction, the speed will reduce. After a point of time, the body may come to rest. That is, your spinal speed becomes 0. Right? And suppose in this process, the body moved up to distance s. Okay. So the kinetic energy is defined as the work done by the opposite force in bringing the body from speed v to speed 0 or to rest. Whatever work has been done by this opposing force, that will be the kinetic energy of this body, the time when the force is applied. Okay. So from that definition, the work done by the opposing force or retarding force will be F multiplied by the distance covered by the body in the opposite direction of this force. That is the work done by this retarding force. Okay. Now, we also know that force applied on a body will be equal to mass into acceleration from the Newton's second law, right? Now let us find this acceleration from the motion in one direction. We know that the equation, one of the equations of equation of motion is equal to v square is equal to u square plus 2as. Okay. In this given case, initial velocity is v, that is u is equal to small v, and the final velocity v becomes 0. It means the speed is decreasing. I am using the term speed because it is unidirectional motion. Okay. Now, because the speed has become 0, it means the acceleration, because the speed is decreasing, so acceleration is negative. So you can write this as a minus a, right? So if we use these terms in this equation, what you will get? V is equal to 0 square, u is nothing but the initial velocity v, which is v square, plus 2 times minus a into s, right? And therefore you can write 0 is equal to v square minus 2as, correct? And therefore you can write that v square will be equal to 2 times a times s. And from this you can write the distance covered by the body will be equal to v square upon 2 times a. Okay. So this becomes the distance covered by the body, right? Now if I deploy this, if I just mark it as a kind of equation 2, this is equation 3, and this is equation 1, then W, that is work done, will be equal to force, retarding force multiplied by S, which will lead to m times A into S from this equation 2, because F equal to ma, and this will lead to m into the acceleration A will be equal to v square upon 2s. So if I write it this way as equation 3 and use this equation 3 in this one, in place of A I can write v square upon 2s multiplied by s. So from this s and s gets cancelled, and that becomes equal to half times mv square. That is the work done by the retarding force for bringing an object with a speed v to 0 if the mass of the object is m. Okay? And that is the initial kinetic energy produced by the body. Therefore, kinetic energy is given as half m times v square. Okay? So let me rewrite it so that you should not have any confusion. So this becomes the equation of kinetic energy, right? So with this example, you would have been very clear that how the gravitational potential energy formula is derived as mgh, and how the kinetic energy formula is defined as half times m, which is mass, into v square, whether v is the velocity of the or speed of the body. Thank you.